Welcome to The Explainer. I am absolutely thrilled you're here today because, well, we're embarking on a truly fascinating journey. We are going to look under the hood of the human machine. We're going to explore the invisible, high-speed operations that are keeping your body alive right this second, a network firing literally millions of signals before you even realize you've blinked. So let's jump right in.
Think about this for a second. How does a fleeting thought instantly become a physical action? It's something we all take entirely for granted, right? You think about moving your hand and bam, it moves. But beneath that seemingly simple action is a chain of events that is incredibly complex. Today, we're going to trace that exact path. We'll start by looking at the macro-level systems of the body, and then we're going to zoom all the way down to the micro-level signals flashing through your brain.
All right, let's lay out the groundwork with Section 1, Form versus Function.
So, to really wrap our heads around how the body works, we first need to establish two absolute ground rules, the fundamental dichotomy of our biology, and that is anatomy versus physiology. Now, anatomy, which comes from a Greek root meaning to cut apart, is the scientific study of the body's physical structures, the bones, the organs, the physical tissues. If you think of your body as a bustling city, anatomy is the physical architecture. Physiology, on the other hand, well, that's the study of the chemistry and physics of how those anatomical structures actually function to support life. So if anatomy is the city's architecture, physiology is the daily operations, the traffic, the electricity, all the action happening within it.
Let's bring this down to earth and think about something as incredibly simple as your eyelid. Structurally or anatomically speaking, it's really just a thin flap of tissue. But physiologically, that specific form is what allows it to snap down instantly to clear away a speck of dust and then slide right back up so you can see. The physical form perfectly serves its protective physiological function. In fact, you could say the physical form is pretty much useless without the physiological function driving the action. You really can't fully appreciate the structure without understanding the action it performs.
Which brings us to Section 2, the quest for homeostasis. Okay, so if physiology is all about function and action, what is the ultimate goal of all these bodily actions? Well, that ultimate priority is homeostasis. That is simply a state of steady internal conditions maintained by living things. The crucial takeaway here is that your body is constantly, quietly working in the background to keep your internal environment perfectly balanced. It's continuously monitoring and tweaking vital signs, like your pulse, your respiratory rate, your hormone levels, just so you stay in a safe, steady state.
Let's look at a number literally all of us know, 98.6 degrees Fahrenheit. While we tend to think of this as a static baseline, it's actually a super dynamic shifting average. Your body is making thousands of little micro-adjustments every single hour, influenced by things like circadian rhythms, just to keep you near this number. This is homeostasis in action, folks. Your body absolutely desperately wants to stay right in this sweet spot.
But what happens when that delicate balance gets thrown out of whack? Step 1 is always a disruption. Let's say external sources, maybe it's a blisteringly hot day out or you've caught a viral infection, raise your internal temperature to 102.5 degrees. Step 2, your body instantly detects this disruption. And Step 3, your physiological systems kick into high gear. You start sweating, your blood vessels dilate, your body does whatever it takes to restore that baseline of 98.6 degrees. It is a constant, relentless balancing act to keep you alive. Which brings up the multi-million-dollar question, who's in charge of all this? What system acts as the sort of CEO of the body to detect these subtle changes and actually issue the commands to fix them?
That leads us right into Section 3, the ultimate control center.
That CEO? It's the nervous system. It acts as the body's high-speed communications network, regulating and integrating basically all your other systems. Now, it doesn't do this entirely alone. It works in close tandem with the endocrine system and its hormones, but the nervous system is the rapid response mechanism orchestrating your survival from moment to moment. And when we say rapid, we mean it. The signals shooting through this network can travel at speeds of over 250 miles per hour. I mean, that is just wild.
This incredibly fast communication network is essentially split into two distinct halves. First, we've got the central nervous system, or the CNS, which is made up of the brain and the spinal cord. Think of this as your main central processing hub. Second, we have the peripheral nervous system, or PNS. This includes all the outlying nerves that connect that central hub to the rest of your body. So the PNS gathers sensory info from the outside world, zips it over to the CNS, and the CNS processes that data and instantly sends commands back out to direct your movement and maintain balance.
Now we're getting to the really good stuff. Section 4, diving into neurophysiology.
Now that we have our structural map, we can zoom way in to the micro level. This brings us to neurophysiology. Simply put, it's the precise study of the brain, spinal cord, and nerves and how they work together to support life. And this is exactly where we see neurophysiology in the larger context of overall physiology. It's not just some niche subcategory, it is the ultimate driver. It is the micro-level chemical and electrical function that allows the macro-level anatomical body to actually achieve homeostasis. We're moving from the big architecture of the brain down to the precise physics and chemistry of a single nerve cell.
So why should this matter to you? Well, because neurophysiology is quite literally driving the most complex, life-defining capabilities you possess: vision, movement, and thinking. Every single time you track a moving object with your eyes, every time you take a step, every time you comprehend a sentence I'm saying to you right now, neurophysiology is allowing you to perform these miracles without a single ounce of conscious effort. It's amazing.
Okay, but how exactly are these messages actually sent? Behind the scenes, your nervous system uses two awe-inspiring methods to communicate instantly. First, it uses electrical impulses. These are the high-speed signals that travel down the length of a single nerve cell. But here's the catch. Nerves don't physically touch each other. There's a tiny little gap between them called a synapse. So when the electrical signal reaches the end of one nerve, it has to completely switch tactics. It triggers chemical neurotransmitters. These are molecular messengers that literally bridge the gap, jumping across the synapse to the next cell to continue the message. So what you have is this continuous lightning-fast relay race of electricity and chemistry.
But as much as we know, we don't know it all. Section 5. The limits of physiology.
It is an insanely sophisticated machine, right? But as we move toward the conclusion of this explainer, we really have to acknowledge a fascinating reality about the limits of our current understanding. Look, we map the anatomy down to the cellular level. We track the electrical impulses and the chemical neurotransmitters with just incredible precision. We know the mechanics. But the deepest biological mysteries, they remain totally unsolved. Science hasn't figured out absolutely everything about how this physiological machine actually generates our lived experience.
Which leaves us with this massive, profound question to ponder. Does the central nervous system directly give rise to human consciousness? The scientific sources note that, sure, while we absolutely know the brain processes our thoughts and sensory data, it is still a matter of huge active debate whether the biological matter of the CNS directly creates the phenomenon of consciousness itself. It is the ultimate biological mystery. How does chemistry and electricity actually become you? Well, I hope this explainer has given you a whole new appreciation for the architecture of action happening inside you every single second. Keep wondering, keep learning, and I'll catch you next time.